Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 4, Section 4, titled Percent of Change. By the end of this video, you will have reviewed the skills necessary to understand percent of change. You will review finding the percent of change and will also look at real-world problem. Then you'll move to percent error. There you will review finding the greatest possible error, finding the maximum and minimum areas. Then you'll look into finding percent error and finding percent error in calculating volumes. If you would like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to my channel if you find this video to be at all helpful. It would help me tremendously. Thank you. Okay, let's look at some definitions before we get going here. Percent of change. Percent of change is a ratio. The amount of change divided by the original amount, expressed as a percent. Percent of increase. When a value increases from its original amount, it is the percent of increase. Percent of decrease. When a value decreases from the original amount, it's the percent of decrease. Greatest possible error. The greatest possible error in a measurement is 1/2 of the measuring unit. So if you're measuring in inches, 1/2 an inch is the greatest possible error. 1/4 inches, it'd be 1/8 of an inch would be the greatest possible error. Percent error. Percent error is the ratio of the greatest possible error and the measurement. Percent of error, the greatest possible error divided by measurement. Okay, objective 1, percent of change. Suppose the price of a sweater increased by $2. You can express the increase as a percent. So the increase in price right here we said was $2. There's the increase in price. Here, see, $2 right here. And the original price, $20. Okay, that's what they're saying here, okay? So then that equals 1/10. 1/10 is equal to 1%, 0.1. So 1/10 is 0.1 is 1/10. And to change this to a percent is you multiply by 100, right? So it was 1, 2. So it would be 10%. Okay? There was a 10% increase in the price. This is an example of a percent change. The percent of change is a ratio. The amount of change divided by the original amount, expressed as a percentage. When a value increases from its original amount, it is the percent increase. When the value decreases from the original amount, it is the percent decrease. Example 1, finding percent of change. The price of a sweater decreased from $29.99 to $24.49. Find the percent of decrease. So the percent of decrease is the amount of change over the original amount. So in our case here, we have $29.99 is the original amount minus the new price, right? We're going to get the change. And the change is going to be $29.99 minus $24.49, and all that divided by the original amount, the $29.99. Then we're going to go ahead and simplify the numerator. You see it's going to be $5.50 divided by $29.99. 550 is the difference between $29.99 and $24.49. $5.50 divided by $29.99. Okay, what do we get? We get 0.18 or 18%. So the price of the sweater decreased by about 18%. Okay, example 1. Solve, right? So we have two problems. A, find the percent of change if the price of a CD increases from $12.99 to $13.99, and then round to the nearest 1%. Okay? And then the second one says find the percent of change if the CD is on sale and its price decreases from $13.99 to $12.99. Round to the nearest percent. Okay, go ahead. Pause the video, please, and try these on your own. And then when you get back, we'll work them together. I'll wait for you. Okay, so I'm sure you all paused the video and you've worked them and you've got good answers. So let's give them a shot. Let's give them a shout out here. Each problem, we're going to look at it and tell what the story is, okay? So find the percent of change if the price of the CD increases from $12.99 to $13.99 and round to the nearest percent. So let's just say what we're going to do. We're going to take, according to the equation, it said we're going to take the $13.99 and we're going to subtract $12.99. Now we know what the difference is. We know the change. We don't, at this point, we don't know if it's a decrease or an increase, but we know what the change is. And we're going to divide it by what? It's an increase. So we're going to divide it by the $12.99. $12.99 because the price is going up from $12.99. And when you do that, we're going to get the answer to this is going to be, this is $1. $1 or 1 divided by 12.99, and that is equal to 0.0769. Okay, so given that, and then if we round that to the nearest percent, we're going to get the 7 is going to round up to an 8, right? So we're going to round this here, and that's going to be equal to 0.8, and then to a percent, we multiply by 100, and we get it equal to 8%, or approximately. I'll say approximately equal to, how's that? 8% and approximately equal to 0.08. Okay, so the 8% for this increase. Now let's look at the same numbers. We're going to do it as a decrease. So now we're still going to take the $13.99 and we're going to subtract $12.99 and we're going to divide it by a number. But what is that number we're going to divide by? Well, now it's dividing by the original number. What's the original number? We started at 13 and we're down to 12, right? 13.99 down to 12.99. So divided by 13.99. And then what does that equal to? That equals to, well, if we do the math, again, 1 now over 13.99. And that equals 0.071479. And then if you take that number and you round it, we're going to say approximately, huh? Because these are both, this is approximate too. It's not an exact number. So approximately equal to 0.07, because the 1 does not cause the 7 to round up. And therefore, the percentage is going to be 7% approximately. Okay, that's the answer on those. Okay, example 2. It's a real world problem. In 1990, there were 1,330 registered alpacas in the United States. By the summer of 2000, there were 29,856 alpacas. What was the percent of increase in registered alpacas? So we have the equation here. Percent of increase is the amount of change. We know how to do the amount of change. And the original amount. We'll just have to, what is the original amount? Okay, in our case, the amount of change is 29,856, right here, 29,856. And where it started was 1,330. So we're going to subtract those. And we're going to divide that by 1,330, the number we started with. We started in 1990 and we ended in 2000. Okay, so when you do that, you're going to subtract these two and you're going to get 28,526. And it's still divided by 1,330. And now when we do that division, you're going to get 21.448 or 2,145%. It's a pretty good percentage. 2,145% increase. The number of registered alpacas increased by nearly, it's approximate too, by the way. I didn't put approximate in here, but it is approximate. By nearly 2,145%. Okay, example 2, check your understanding. Now we want you to go ahead and pause the video and try this. And you don't really even have to try pause it. We can just go through it. I already have the answer in front of you. So let's go ahead and let's just go over it together, okay? The number of alpaca owners increased in 1946, from 146 in 1991 to 2,919 in 2000, the year 2000. Find the percent of increase. Round to the nearest percent. Well, here's our formula again, percent of increase, right? Increase, amount of change over the original amount. That doesn't change for any of these, actually. So the percent increase is 2919 minus 146 divided by the original amount, which is 146. When you subtract these two up here, these two right here, you get 2773, and you're going to divide that by 146. When you do that, you're going to get 18.99 or 1,899%. The increase in registered alpaca owners is 1,899%. Okay, objective 2, percent error. It says 2A there, and this is the second. There's going to be two slides for the objective slides, but the other one will come a little later. Think about the last time you used a ruler. You probably measured to the nearest inch, half inch, centimeter, millimeter. You had some amount you're measuring to on your ruler, right? Okay, because no measurement is exact. You always measure to the nearest something, like to the nearest inch or quarter inch or half inch, right? So the greatest possible error is a measurement. Excuse me. Error in a measurement is 1/2 of that measuring unit. So if you're measuring in quarter inches, 1/8 of an inch is your greatest possible error. If you're measuring in millimeters, then 1/2 a millimeter is your greatest possible error. Example 3, finding the greatest possible error. You use a beam balance to find the mass of a rock sample for a science lab. You read the scale as 3.8 grams. So grams is your measuring unit. What is your greatest possible error? So here it is, the rock's mass was measured to the nearest 0.1 grams. 0.1 grams. So it's grams. But now since we've qualified that and now say that it's 0.1 gram, our unit of measure is 0.1 gram. So the greatest possible error is 1/2 of that. 1/2 of 0.01 grams is 0.05 grams. 1/2 a gram. 0.05 grams. Okay? Okay, example 3. Check your understanding. I'd like you to stop it and pause it and try this. You measure a picture for the yearbook and record its height as 9 centimeters. What is your greatest possible error? Why don't you pause, think about this. If you already know, you don't have to pause. I'm waiting. I'll come back later. Okay, we're assuming you've done that. Let's take a look. So what is it? Says that we measured 9. Oops, I'm in the wrong spot. 9 centimeters. Okay, let me erase this other piece. Bingo. Okay. 9 centimeters. Well, what are the units? Well, it's unit 9. So it's like 1, 2, 3, 4, 5, 6, 7. These are integers, right? So a centimeter is the unit. It's not a tenth of a centimeter, a half a centimeter. A centimeter is the unit. Well, our greatest possible error is 1/2 a centimeter, 0.5 centimeters. Okay, example 4. Excuse me. Now we're going to look at finding maximum and minimum areas. You measure a room and make the diagram shown at the right. There it is. The room is 7 by 13 feet. See it? Use the greatest possible error to find the maximum and minimum possible areas. Okay, based on those measurements, you're going to have the largest possible area and the smallest possible area. And this 13 times 7 will fit somewhere in between those. So both measurements were made to the nearest whole foot. Okay, so the greatest possible error is 0.5 feet. The length could be as little as 12.5 feet or as great as 13.5 feet. The width could be as little as 6.5 feet or as great as 7.5 feet. Find the maximum and the minimum areas. Well, the minimum area is, we're going to use the smaller numbers in each case. The as little as numbers, right? So 12.5 feet. It was 13. Now we're using the smaller one, 12.5 times 6.5, which is the smaller from the 7. It's 1/2 foot smaller because we said that 0.5 feet is the area, the minimum, or this, right, the possible error. And that will equal 81.25 feet squared. And the maximum area is 13.5, not 12.5, not 13, but now it's the upper end, the 1 foot greater. 13.5 times 7.5. 7 was the original size that we measured, but you have to add that 1/2 foot on for the greatest possible error. So 13.5 times 7.5 feet is 101.25 feet squared, or square feet. So the minimum area is 81.25 square feet, and the maximum area is 101.25 feet squared, or square feet. Okay. And the actual measurement of 7 by 13 will fit somewhere in the middle there. Okay. Okay, example 4, check your understanding. Go ahead and pause the video and try this on your own. When you come back, we'll do it together. What does the problem say? It says you measure a wall of your room was 8 feet high by 12 feet wide. Find the minimum and the maximum possible areas of the wall. And I gave you a few columns to write some info down to kind of organize with if you'd like. Go ahead and pause. When you come back, we'll work them together. Okay, so now that you're back, so what do we do? What is the measurement? It was 8 by 12, and that equals 96, right? Feet, these square feet, I should say square SQ feet. Okay, what are the units? The units are feet, but the maximum error is going to be 1/2 a foot. So it's going to be 0.5 feet. Okay, now over here, make this is a little messy. I'm going to clear that up for you because I'm going to say this. I'm going to go back over here, and I'm going to say is equal to 96 square feet. Okay. So now, so what is the minimum area? Well, the minimum is this 1/2 a foot taken from each one of these measurements. So if we did it, it's going to be 7.5. That's a 1/2 foot removed from the 8 times 11.5, which is a 1/2 a foot removed from the 12. And that equals what? It equals 86.25 square feet. Okay, that's the minimum. What is the maximum? Well, the maximum is going to be the 1/2 a foot added. So it's going to be 8.5 times 12.5. And that, I could say feet and feet on each of those. And that equals 106.25 square feet. Okay, and that's it. It's that simple. You take the lesser bound and in this case, and multiply and the higher bound. Okay. So objective 2B, it's that second slide in percent error. Percent error is another useful way to think of the error in a measurement. It is the ratio of the greatest possible error, which we just learned about, and the measurement that you took to get that error, right? Okay. Same formula, basically. When you look like a percent error right here, percent error is the greatest possible error over the measurement. So it's always kind of this something over the measurement, over the measurement. Okay. Example 5, finding the percent error. Suppose you measure a CD and record its diameter. as 12.1 centimeters. Find the percent error in your measurement. Since the measurement is to the nearest 0.1 centimeters, you saw it right here. You measured to 0.1. It could have been 12.6, but you would have still said that it's a 0.1. You're measuring to the 0.1 accuracy, right? 0.1, 0.2, 0.3, 0.4. It was all point with one decimal place. So it was 0.1 centimeter is the accuracy, we like to say. The greatest possible error is 0.05, 1/2 of 0.1 centimeters. So you have to change the 1 to a 0 and put a 5 after it, right? So it's a half of a tenth of a centimeter. Okay, so now you know that the percent error is the greatest possible error divided by the measurement, and we're going to use this percent error formula. So what do we get? What is the percent error? The percent error is, we said, it's right here, 0.5 centimeters, right here, 0.5 centimeters divided by the total error, the original number. And the original number is right here, 12.1 centimeters divided by 12.1 centimeters. That's substituted into the formula here. And what do you get? You get approximately 0.00413222314, and it goes on. And that's why it's approximate. Okay? And when you convert that into a percentage, because they want to know the percent error, you have to multiply this 0.004 number by 100. And when you do that, you get 0.4%. The percent error is about 0.4%. Okay, example 5, check your understanding. So as you know, I'd like you to pause and try these on your own, but I'll read them first. You measure the length of a table as 168 inches. Find the percent error for this measurement. Here's problem B is you measure the length of a table as 168.0 inches. Find the percent error for this measurement. Okay, I'll wait for you. Okay, so let's take a look at these. So what do we have? Same thing. You measure the table, it's 168 inches. Find the percent error. Well, you see it's inches, so the least significant unit here is 1 inch, right? It's in integers, right? So it'd be like 1, 2, 3, 4, 5, 6, 7, 8. So it's a solid whole integer, 8. So that means it is solid inches, whole inches. There's no fraction. There's no dot something. It's just whole inches we're measuring. And in doing that, we're finding the error. So 1 inch, the greatest possible error here is 1/2 an inch. So we say that 1/2 an inch, 0.5 divided by 168, substituting into that formula, we get 0.00297,619. That's our error. Now we have to convert it to a percent error. And you do that by rounding the 2 to a 3. The 9 rounds the 2 to a 3, and you move the decimal place 2 times, and you get approximately 0.3%. Okay, problem B, you measure the length of a table. All right, now this time it's 168.0. So you literally measure to a tenth of an inch because it's got the tenths now. Find the percent error. Well, if you're measuring to tenths, the percent error is how much? It's 0.05. This is 1/2 of a tenth. Here's your tenths, and it's 0.5 of that tenth. So it's 0.05, right? So here it is, 0.05 divided by 168. I said 0.0. Yeah, since it was 0, you don't even need to add the 0, but we do for consistency. So then when you substitute, you're going to get 0.000297619. And again, the 2 is going to round up to a 3. That 2 will round to a 3. And when you do that and you multiply by 100, you're going to get the decimal place moving from here to here to here. So you're going to get 0.029, or 0.3, 0.03%. Okay, example 6, finding the percent error in calculating volume. Okay, so there's a few more steps in doing this, but they're not difficult steps. The first steps are exactly what we've been doing so far all along. The diagram at the right shows the dimensions of a cassette case. Find the percent error in calculating its volume. The measurement are to the nearest 0.1 centimeters. 0.1. You'll see that in here on the diagram. If I point them out, right here, 0.1, right? It's point. 1/10 is the accuracy we're talking about here. So it says measure to the nearest 0.1 centimeters. The greatest possible error is 0.05. It's a half of the 0.1, 0.05. All right. So here's our formula. Volume is length times width times height. And we have them as measured, which is 1.6, 6.8, and 10.9. Let me change color so you can see what I was just marking. 1.6, 6.8, and 10.9. So we're going to fill that in, 6.8 right here, 1.6, and 10.9. And then when you multiply those up, you're going to get 118.59 centimeters cubed. 118.59 centimeters cubed. The maximum value is you're going to take the maximum, right? So it's, in this case, it was 6.8, but now we have to raise it by 0.05. So the answer, the number is going to be 6.85, and it's 1.65 because a half, a tenth is added to each, and but times 10.95. And when you do that, you're going to get 123.76 centimeters cubed. Cubed because it's centimeters times centimeters times centimeters. So that gives you centimeters cubed. So 123.76 centimeters cubed. And now the minimum value is you're going to subtract that half, a tenth centimeter from each number. So instead of it being 6.8, it's going to be 6.75. You subtracted 0.05. And it's going to be 1.55 instead of 1.6 because you subtracted a 0.05. 10.85 and not 10.9, right? It's one half, a tenth less, 10.85. When you multiply those out, you're going to get 113.52 centimeters cubed. Well, so you see that the as measured, the middle value it would be considered here is 118.59, and it is between 123.79 and 113.52. It's right in between them, somewhere in the middle there, right? In fact, exactly in the middle, probably, right? So, given that, now we're going to say we have to find out the possible errors for each. Well, the possible error is you take the maximum value, okay, and subtract the measured values. So here we have 123.76 minus 118.59. Or right here, I'm going to change colors. Let's see, let's try this yellow. How's that? You take your 123.76 from here, and you subtract the as measured value, 118.59, and you'll get 5.17. If you do the minimum, you're going to get 118. You're starting now with 118, and you're going to subtract the smaller one from the as measured value. The as measured, again, comes from way over here. And now you're going to subtract from that the minimum value. Minimum value right here. And it's going to be 118.59 minus 113.52. So you'll get 5.07. Well, back when it told us what to do, it said to subtract the largest difference. Use the largest difference in our calculation. So use the difference that shows the greatest possible error to find the percent error. So the one that shows the greatest possible error is not the 5.7. No, it's the 5.17 is the greatest possible error. Okay, and when you do that, you take 123, right? We look at it, 0.76 minus 118.59 divided by 118.59, and you get the 5.17. That's our maximum number. You could have just taken the number directly from here. And then you just divide it out. 5.17 divided by 118.59, you're going to get 0.043595584 right here, 814. And that will be 4% because you're going to take your decimal place and you're going to move it 2 places. So you're going to get 4.3%. That's your greatest possible error. Now, suppose you measured your math book and recorded the dimensions as 1 inch, 9 inches, and 10 inches. Find the percent error in calculating its volume. Well, this is your chance to go ahead and give it it's check your understanding. So try this one and see what you come up with. I'll give you some time to do it, and then we'll get back together. Pause the video. Okay, I'm sure that you've done that in your back. So suppose you measured your math book and recorded the dimensions as 1 inch, 9 inches, and 10 inches. Find the percent error in calculating its volume. So the same steps we used in the last slide. Length, width, and height. So I have the length of the book is 10, the width is 9, and the height is 1. So I'm calling the thickness of the book the height, like it's laying on its back, right? So 9 times 10 times 1 is 90 inches cubed, right here. 10 times 9 is 90, times 1 is 90 again, and 90 inches cubed. Okay, it says approximate. It's not even approximate. It's exactly that amount, but it doesn't matter. So how about this? The maximum value is length, width, and height. We're going to add the ½ inch. Since we're in inches, it just says inches, inches, inches. So we can have ½ inches is our half units, right? So over here we got 10 and 10 and a half plus 9 and a half plus 1 and a half. And when you multiply that, you're going to get 149.625 inches cubed. Okay. And then over here for the minimum value, you're going to get 9.5, which is 10 minus 0.5. And you get 8.5, which is your 9 minus 0.5. Here's the 9 way over here, 9 minus 1.5. And then 0.5. 1 minus 0.5 is 0.5. And when you multiply that up, you're going to get 40.175 inches cubed. So let's find what are the possible errors. 149, it's this one here, minus the 90, which is way over here. And you're going to get 59.625. And for the minimum, you're going to do what? You're going to take the 90, you're going to start with here, and you're going to subtract the smallest value from it, which is going to be the 40.375. 90 minus 40.375 is 49.625. What's the percent here? Take the largest number, take the largest error difference, and divide it by the original number. So in our case, it's 59.625 divided by 90, was which we calculated the original numbers. And we're going to get 0.6625 inches cubed, written as a decimal. And when you write it as an integer, you're going to move this decimal point 2 places. So you're going to get 66% rounded and written as a percent. Good.